Okay, what day is today? The 16th of December. Okay. Today. I was just a second. I was just testing this. Okay. Let's make an intro. Welcome back. So, today, I'm planning to refresh my knowledge on some interview questions. That's why I have my good friend, the tablet here. I'm gonna write a lot today, most probably. Uh, Also, I think I might. I'm gonna try to get in some some deep learning work, and that's it. I'm learning. I'm going with the flow. I should make these streams more organized, definitely. For some reason, I don't. And for some reason, I have 190 subscribers. So thank you all, and whoever is watching this. But let's start. Let's start. So I did this the last time. I started learning about hash tables, and that's it regarding hash tables. But now let's do something else. I'm gonna use the same method of using mind maps, and mind maps are just a way of structuring stuff by creating. Why is this? It's because I have it creates perfect shapes because I had the settings for it enabled, and now it won't let me delete it. Yeah, maybe like this. Okay, I disabled it. So let me basically put a bigger font here just to kind of make a title. This is too big. 45. So now what I want to talk about are, this is too big as well. All right. Let's use 35. So I'm gonna talk about array, list, and resizable arrays. Okay, let me just turn this to maybe 15. Maybe this is too small. Maybe 20 is okay. I don't know. Not in the mood to think much about this. But basically, so array list. I don't think I've ever used a language that had array list in it. So let me just make sure to see. There are some languages that have array list because I'm interested in it. So several programming languages have a dynamic array or array list equivalent that allows you to manage a resizable array. So some of those programming languages are what? Java, of course. Java. Oops. I'm messing everything up. I don't usually do this. Yeah, let's move this up. Okay. It's not me. I mean, it is. I'm a pretty clumsy person. So Java, C Sharp. I know that Java specifically has. So I'm just gonna add here some languages. So it's Java, C Sharp, C Sharp. Ah, okay, it has a list of type T, in which T is a generic parameter. Python. Oh, I didn't know that Python had idem. I mean, it's built in. It's not a specific, right? JavaScript arrays are dynamic and can be resized at runtime, similar to ArrayList. I know this, but does any programming language has specific? Ruby, C, C++. All right. So, in some languages, arrays are automatically resizable. So the array will grow as we add elements on it. And in other, like Java, arrays are fixed length. The size is defined when you create an array. Okay, but what if we need a array-like data structure that offers dynamic resizing, and we would use something in Java called array list. And basically it's just an array that resizes itself as needed while still providing 0-1 access, basically instant when it comes to calculating the speed of the computation. So that's it. But how are these implemented? When you need an array-like data structure, all right. So how is it implemented? So when the array is full, the array doubles in size, and each doubling will take O(n) time, but happens so rarely that it's amortized in insertion time still O(1). So by doubling when full, right, and this takes O(n) time. All right. So, but I mentioned that O(n) is only the doubling, but the amortized insertion runtime is still O(n). So, what does this mean basically? Oh, sorry, I wasn't there. So let's say we have an array of size n, and we can work basically. Okay, so we have an array of size n, and we can work backwards to compute how many elements we copied at each capacity increase. And when we increase the array to a certain amount of elements, the array previously was half its size. So if this is an array that we looked at, so this is the final size. But before that we had n divided by 2 elements, and before that we had n divided by 4, and before that we had n divided by 8, and every time we need to copy those elements. So basically at first time what we need to copy is let me divide is and 2 elements plus and 4 plus and 8 plus blah 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 plus, I don't know, we start from 2, we start from 1. This is still smaller than n, because we never make it to n. It's still smaller than n. So inserting n elements will take O(n) work total, and each insertion is all O(1) on average. You know, even though some insertions take O(1) at worst case. Yeah. So yeah, I basically said this. If there is space available, inserting a new element is a straightforward operation. But when it's full, we need to resize. We need to allocate a new array with a larger capacity, which is typically double the size. And you know, although resizing takes O(n) time, it happens pretty infrequently, and it only happens when the array is full. Now, there is this concept of something being amortized, and what does this mean is the average running time per operation over a sequence of operations, and it basically smooths out the operation in the end by expanding their cost over many other cheap operations. Basically, when we insert a new element into an array that, for now, let's say has only 3 places, so insert once, twice, 3 times, then we double, and doubling takes O(n), but then we have another 3 places, then we have 6 places, then we have 12 new places to insert our new elements. And I think this is basically it. There's also the string builder. So here it says, imagine you were concatenating a list of strings. And what would the running time of this code be? For simplicity, assume that the strings are all the same length and that they are n strings. All right, let's try. Let's try to take a look at this. So this is basically a interview question of some sort. So let's increase this a bit. Imagine joining a list of strings. So what is the running time of this code? All right, so imagine that all strings are of the same length and that they are n strings. So we can create a method. We can check for each string and we can just so we can start with an empty sentence. So it can be a string can be empty, and then for each word in words we add the word to the string. So we have a new copy of the string that we created, and we have the two strings that we copied over character by character. So if we have let's say something that consists of this A, B, C, D, E, F, G, H, L, M. Okay, let's I don't know the English alphabet so well, but let's do this one. So basically, the first iteration, we're gonna copy the 4 characters that we have into the string. Now the second time, we are copying 2x because we already have ABC. We already have the string which is ABCD plus AFGH is equal to string. So we are copying 2x the amount of characters. Now the third time we have 3x. So what's the runtime of this? It's O x n squared, where x is the length of the string itself. So yeah, if you want, so I need to make a way to explain this simpler. But basically, when we concatenate strings in a loop, and each new loop, each new concatenation involves, so we need enough memory and enough space in memory for the resulting strings, and then we need to copy all the characters from the existing string into the new space, and then we need to append the new string to the end of this string. And if we have n strings of length x, as I wrote here, and if I concatenate them in a loop, so step by step, on the first iteration, results of course empty. The string is empty. So when we append the first string, it will take x time to copy. So basically, we are only copying the character that we have. But on the second iteration, now result has the first string. Now concatenating the second string involves allocating space for 2x amount of characters, and then copying the x characters of result plus the x characters of s. which means that the cost is 2x. And then on the third iteration, we have 3x. On the last iteration, we have the same thing. So basically on each iteration, what we have? We have I minus 1 x, because we are looping from the 0th index, x characters. And we do the same thing. So what is the time for this? So the time is it's x plus 2x plus 3x plus like this plus nx, which is then x1 plus 2 plus 3 plus dot 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 plus n, which is then we need to create a sum of this, and the sum of this is, if you remember from math, is basically x times n plus 1 divided by 2, and then the total time is what do we have here? We have if I multiply this, it's gonna be xn xn plus x over 2. Now if we multiply this, it's gonna be wait, I did something wrong here, I think. Yeah, I know that it's wrong. So this is actually, oops, this is actually xn squared 2 plus xn 2. And because the n squared term dominates, we can remove all the constants, so it can only be oxn, which is the asymptotic notation of this. And it's quite inefficient, basically. But okay. I think that's it. I have nothing else. I have a couple of examples for interviews. For example, implement an algorithm to determine if a string has all unique characters. What if you cannot use additional data structures? But this is from the book. I can... should I open LeetCode? All right, so let's do a couple of examples. I'm gonna I'm gonna increase this. So let's do some interview questions. And the first one is unique. Basically, implement an algorithm to determine if a string has all unique characters. Okay, if a string has all unique characters, oops, sorry, I almost locked this out. Okay, so we need to implement an algorithm to determine if a string has all unique characters. What if you cannot use additional data structures? All right. So all right, I have this. Yeah, I trust myself. I trust myself wholeheartedly. So I have this script that I already started working on. And I'm gonna create, I really like this interview questions. I should use an underline questions dot epy. What's the name? I always forget the extension. Why did they make an extension have 5 letters? It's Python NB. Python NB. All right. So I'm using Python. I usually use JavaScript mostly, but yeah, markdown code. Can I move this up? Insert cell, switch cell tab. Can I move you up? No, let's remove. Let's put the markdown first. So this is called is unique, and I need to write here all right, implement an algorithm to determine if a string has all unique characters. What if you cannot use additional data structures? This is too big. Maybe I can use you like this, and maybe I can remove the type here completely. Yeah, I like this. Why are you above? No. Here, code. All right. So, what can we do here? So, let me just open the tablet again. So what I can do here is the simplest thing. I already had these kinds of questions on my interviews. Basically, I can create a set to keep track of characters. So how can I do this? is like this. So def is unique with set. What am I taking? I'm taking a string. What am I producing? I'm producing a boolean. Why can't I run this? I can't run this because, let me just print test. I can't run this because I haven't set up my environment. It's here, now it works. And this isn't string, this is a str. Can I, if I, no, I can't. I was thinking maybe I can use the shortcuts for creating bold text and everything, but no, it seems like I can't. So I create a set of scene elements. Now I take individual car. If car is in scene, I can return false. Otherwise, I add car here. I return true. Is this working? Also, let me increase this a bit. Why is this not working? What? Return true, but I don't want to. Why? Oh, it needs to be here. But why? Oh, I need to unindent all of this. Yeah, now it works properly. Now I can use print is unique with set. I can use hello. I can use print is unique. It's really simple. This is like, I don't know why I'm even doing this. So I can running cell, install. False true, nice. So why is this happening and what is happening here? Is that we have a set, it keeps track of our characters, and this approach has a time complexity of O(n) and a space complexity of O(n). Why has it a time complexity? Because we just iterate through the array, and space complexity because we fill the new set made out of elements consisting in the request. Okay, but how to use this? Let me create another code. How can I create where? No, not the markdown. The code, brother. Okay, the code. So same thing. Is unique with no. It's unique. Let's just write. Let's call it is unique. String produces a boolean. So let's say I have, or I know about the sorting algorithm. So I'm just gonna sort this, and then I'm checking for E in range of what? Of sorted as. I don't need, oh God, I always forget. I don't need this. So if sorted s of I is equal to sorted s of I plus 1, return false, otherwise return true. Really simple. So I'm just going to repeat this. And if I run all of these, I need this here. I also, okay. I almost didn't catch it, because what would happen, I would come to the last element and I would try to compare it with the next one and it will fail. So now if I run, yeah, still works the same. All right. So let me copy all of this. Let's create a new markdown. And this question is called check permutation. And it says here, given two strings, write a method to decide if one is a permutation of the other. So I have two strings. I need to write a method to decide if one is a permutation of the other. So the thing to note here is that what does it mean that if a string is a permutation of each other? It basically means that they have the same length, they have the same, they contain the same characters. So how we can do this? We can basically do this. We can def is called check permutation. I'm taking string 1, which is a string. I'm taking string 2, which is a string. I'm returning a bool. So immediately, if the length of S1 is not equal length of S2, they are not equal, returning false. Otherwise, I'm gonna, again, let's say I sorted this already. There's a sorted algorithm. S2, and let's use two examples here. Check permutation. Run all. Works. No, but wait. This is ABCB. What if I say DFF? Nice. Again, there's also the more complex, let's say, version of this, in which we count we count the occurrences of each characters, but I'm not interested in this right now. So let me also do a lead code example. So where am I storing this data structure? No, I started something. But no idea what. Where is the this top interview 150? I already started some of these. Okay, remove duplicates from sorted array. This is a more complex example, it seems. What does it say here? All right, so we need to do it in place. Okay, so let me think. Let me try to open this and to show this an example of it. So the array is already sorted, which means that duplicates are grouped together. Okay. We can't use extra memory. We can't create a new array. Okay. So we must modify the array in place. And each unique element can appear at most twice. So what can I do here? All right, I think we need to use 2 pointers here. Let me close this. What do I return? All right, so if the length of nums is less or equal than 2, just return length of nums. So no need to process if the array has 2 or fewer elements. Okay, yeah, this makes sense. Now let's create a pointer. Right, pointer, but maybe not here, but here. And that's equal to now 4. So now we iterate starting from the second element, right? All right, so if so what we are checking, we are comparing the current element with element that's 2 positions before the right pointer. So if the word is, no, if we have these numbers, 1, 1, 1, 2, 2, 3, so the right pointer is 2, and the read is 2 as well. So if this element is different than this element, we will do something, but because it's not, right pointer 3, then I increase right 1, and then I return right pointer. All right, now if I run this, It should pass, I think. No, why? Where do I have? Ah, it should be right pointer. So read and write. Yeah. I should have just left. Yeah. If I click submit. Easy. So how it works. I also want to walk through this. I also want to walk through this. So if we have these arrays, so this is where we are starting, and we have the right pointers starting at 2. So both the right and the read pointer are here. And now I compare this element with the one that is right minus 2, which is here. So this is right minus 2. So what happens here? Because they are equal, we're not doing nothing. So we come to the next iteration. Now here we have both write and read. Sorry, not both of them. Only the read one. And the write is still here. Now I compare this element to the element which says write minus 2, which is 2 compared to 1, because 2 is different than 1. What happens? We are writing two here. And we just do this till the end. Yeah. Sorry, I forgot to show you this. So yeah, that's basically it. Okay, what else did I want to do? I have submitted the solution, right? Yeah, it works. All right. All right, I need to stop here. Sorry, guys.